Good afternoon, everyone. सिर्फ ऑलिवर भी याद रखा तो भी चलेगा. Fine. इस anomalous temperature में just remember the Oliver. And example 1, that is the British type of climate due to the maritime effect. Second example, which map is easiest for you to draw? Europe or North America? चलो North America. The interiors of North America. The interiors of North America. Light. The interiors of North America experiences extreme climatic conditions. अब इसमें obviously cold, warm सब कुछ extreme climatic conditions due to the continentality, due to continentality or continental effect. Due to continental effect or continentality. Or continentality or continentality. See, east anomalous temperature may even this can come, Labrador current. This part is extremely cold due to the Labrador current. You can take any of the examples in the east anomalous temperature. When the temperature of a place is lesser than normal, when the temperature of a place is lesser than normal, it is known as negative thermal anomaly. It is known as negative thermal anomaly. It is known as negative thermal anomaly. Now, one conceptual part, यहाँ तक तो simple है. One conceptual part, if this is a continent, this is the equator, this is the Tropic of Cancer, 23.5 degree north, and this is the oceans, this is the land mass. And if this is the Tropic of Capricorn, and during the winter season, sun is obviously over the Tropic of Capricorn. Fine? During the winter season, the sun is over the Tropic of Capricorn. Tell me how will be the thermal anomaly in the northern hemisphere? कल का अगर टॉपिक समझ में आया तो you have an answer. During the winter solstice, the northern oceans will have positive thermal anomaly या negative thermal anomaly. Why positive? Temperature ज़्यादा है of ocean as compared to land. क्यों? Because of the specific heat. मतलब water will take time to get heated. When the sun is in the southern hemisphere, fine, That is winters. Winters mein land will be cooled very fast, but oceans will be comparatively warmer, and therefore we can say the oceans will be having a positive thermal anomaly. Conceptual part. Depending upon how long the question is, kya likhna hai kya nahi, that is choice is yours. Fine. So next, the thermal anomalies are basically caused. The thermal anomalies are basically caused due to distributional pattern, of land and water, due to the distribution pattern of land and water. During the southern summers, the northern hemisphere, southern summers अगर complicated नहीं लिखना है तो ऐसे लिख सकते हो during winter solstice. During the winter solstice, the oceans in the northern hemisphere experience positive thermal anomaly, and therefore an isotherm traveling from ocean to the land, will bend southwards. And vice versa. Suppose this is a 25 degree Celsius का isotherm. Isotherm is the line joining places of equal temperature. It is traveling, यहाँ पे all this ocean water is having 25 degree Celsius of temperature. But land is cooler because land will cool very fast. So 25 degree Celsius of temperature land में कहाँ होगा? Towards the equator. Therefore isotherm कैसे bend करेगा? नीचे. Understanding? Can I continue? Understanding this concept? यही NCERT में लिखा है कि the isotherm during the winters bends towards the equator, डायरेक्ट लिखा है, बट वो क्या है? थर्मल एनामोली. Can I continue? Next, the largest of all the thermal anomalies, both positive and negative, are seen in the northern hemisphere due to the dominance of landmass. And therefore, the isotherms in the northern hemisphere, are irregular and not parallel to each other, and not parallel to each other, are irregular and not parallel to each other. While the isotherms in the southern hemisphere are more or less regular and parallel to each other. Isotherms in the southern hemisphere are more or less parallel and regular. And draw this world map. Isotherms are used to determine the world distribution of temperature, and thus we see how the isotherms are. It can be of any month. हमें detail में करना नहीं है. It's starting straight over the ocean and then it is bending as it goes on the land. Land में it is again bending because land में there are mountains etc. Then it becomes straight over the ocean. It again bends. यहाँ पे the isotherms of Himalayas are different because mountains में अलग climatic conditions होगा. कॉन्टिनेंटल क्लाइमेट है, उसका अलग कंडीशन है. सहारा है, उसका अलग आइसोथर्म है. Looking at the spacing within the northern hemisphere and the southern hemisphere. Southern hemisphere का कहना है इसे widely spaced and parallel to each other. Northern hemisphere का कहना है इसे closely spaced and irregular. I'll tell you. Choice is yours if you want to draw Antarctica or not. कैसे भी इरेगुलर बनाओ, ज़रूरी नहीं जिस पैटर्न में मैंने बनाया वैसे ही. द ओनली थिंग इज यू शुड रिमेंबर कि इंडिया का क्लाइमेटिक में कोई स्ट्रेट लाइन नहीं आएगी. It is impossible कि you will remember exact position of the isotherms because isotherms का position will keep on shifting with the months. जनवरी का अलग होगा, फरवरी का अलग होगा. So जैसे बनाना है वैसे बनाओ. The only thing is straight नहीं बनाना है northern hemisphere में and irregular बनाना है. Now the question is why it is closely spaced, why it is widely spaced. Is the climate of Sahara same as the climate of Mediterranean? यहाँ पे there are Alps, so climate changes. यहाँ पे there are Himalayas, climate changes. Shape of Indian continent, climate changes. यहाँ पे there is no change of climate. So because the rate of change of temperature is very high, so कभी यहाँ पे 20 डिग्री सेल्सियस का आइसोथर्म है, कभी 30 डिग्री सेल्सियस का है. यहाँ पे एक अलग आइसोथर्म है because it is mountain. So closely spaced isotherms determine there is a frequent change of temperature due to dominance of land mass. Means in our technical language, closely spaced isotherms determine that temperature gradient is high, rate of change of temperature is high. Southern hemisphere में because there is no land mass, there is dominance of oceans, temperature remains more or less constant. टेम्परेचर क्यों चेंज हो रहा है? क्योंकि अरावलीज है, क्योंकि हाइट ऊपर नीचे है, सॉइल है, सॉइल का कलर्स डिफरेंट है, अल्बिडो इज डिफरेंट एंड देयरफॉर टेम्परेचर ग्रेडियंट इज हाई. So just remember general, never write it in the exam. Closely spaced isotherm determines high temperature gradient. ग्रेडियंट इज रेट ऑफ चेंज. सेम डायग्राम को अगर मैं लिख दूं, इट विल बी ट्रू. ओनली थिंग इज प्रेशर. सीन टुडेज एसे पेपर इजी था पिछले साल से. सेक्शन ए में क्या, लास्ट के दो बहुत आसान है. पर्सनल इंटरेस्ट में नॉट बी ऑलवेज गुड फॉर द सोसाइटी. सक्सेस ऑफ अ पर्सन इंडिविजुअल इज नॉट ऑलवेज गुड फॉर द सोसाइटी. यू कैन राइट अबाउट कैपिटलिज्म, यू कैन राइट अबाउट पॉलिटिकल सक्सेस, यू कैन राइट अबाउट करप्शन. सोसाइटी में एथिक्स होनी चाहिए, इक्विटेबल डिस्ट्रीब्यूशन ऑफ रिसोर्सेस होना चाहिए. सक्सेस ऑफ सम पॉलिटिशियन में ऑलवेज नॉट बी गुड फॉर इंडिया अगर उसका आइडियाज आर डिफरेंट. यू कैन टेक एन एग्जांपल ऑफ हिटलर. ऐसे क्या है, सिर्फ इमेजिनेशंस लिखना, लिखो हिटलर का सक्सेस एंड उसका इल इफेक्ट्स. And section B तो was very easy. Last essay was section B, Industrial Revolution 4, that is artificial intelligence. Joblessness, yeah, more jobs, depends upon skill development. Fine. So this is all about the thermal anomaly. Getting it? And the next topic is very easy topic, that is the temperature inversion. what is the temperature inversion? आवाज घूम रहा है. The temperature inversion is a condition कि in the normal there should be cold air, then it should, नीचे ground पे there should be warm air. After that the air will become cool. After that it will become more cooler, and after that it will become more cold. So ऊपर हमेशा there is a dense air, cold, and नीचे there is a warm air. But if the condition is exactly opposite, कि नीचे there is a cold air and ऊपर there is a warm air, then it is known as a temperature inversion. A temperature inversion, why it occurs? It is of two types. Remember, one is non-advectional inversion and second is advectional inversion. The non-advectional inversion will occur. What do you mean by advection? Horizontal movement of air. So it will occur whenever there is no movement of air. Matlab in the absence of winds. This will occur whenever there is a movement of air, and it is divided into numerous patterns such as frontal inversion, valley inversion, sea, smoke and fogs. But more importantly, हम यहाँ पे ऑप्शनल में पढ़ेंगे Now, why it is known as an upper air inversion? Just understand one simple thing. जब तक GS में you must have studied this thing, that during the winter season the land becomes very, very cold, and therefore the parcel of air which is coming into immediate contact with the land will become cold. Fine, this parcel of air will remain cold. Air is not a good conductor or a mixture of heat. Matlab, heat does not easily go. So this on the land comes in the winter season, the land becomes extremely cold. Maybe there is a snow cover. Itna thanda hai ki you will start wearing socks, and therefore air which comes into the contact with this cold ground surface will become very cold. Air is in a bad mixture of heat, and therefore heat will not be mixing. Hence नीचे का air will remain cold, but ऊपर का air, because heat does not mix, will remain comparatively warm. This kind of an inversion which occurs where near the ground is known as a ground inversion. अब क्या क्या conditions है for the ground inversion? The condition for the ground inversion is one, that is winters. Now how are these winters? These are long, cold winter nights. Now why the word long? It is because it is very obvious that during the winter season days are shorter, nights are longer. जितनी लंबी है रात, जितना the night is longer, utna the ground will lose more heat by the process of radiation. Jitna days are shorter, utna the day will receive less heat by the process of insolation. So incoming कम हो जाता है, outgoing increases, that is outgoing heat increases, incoming reduces, and therefore over the period of time temperature keeps on dropping. Second is no moisture, or the second best is presence of dry air. Why dry air? Because in case if there is a water vapor here in this air, this water vapor means moist air, it will trap the heat that is being lost through the terrestrial radiation, because water vapor is a greenhouse gas, and if this traps the heat, then this layer will not become colder, and hence the presence of dry air near the ground. Thirdly, if the wind is coming from here, this wind will result into mixing up of warm and cold air, and we don't want mixing to occur, because there has to be two separate layers of the cold and warm, and therefore the third condition is no winds. And the fourth condition is no clouds. Why no clouds? Because if the clouds are present here, the clouds will trap the heat and reflect it back to the space. As it reflects it back to the space, there will be no reflected back to the earth. As it reflects it back to the earth, there will be no temperature inversion, and hence there will be no effects of the temperature inversion. Now, what are the effects of the temperature inversion? One of the effect of the temperature inversion is at this boundary there is a low lying cloud which is known as fog. Fine. Cold air will cool the warm air from below. As a result of this, there will be condensation, means cooling. Water vapor will get converted into water droplets. Clouds नहीं बनेगा because moisture content इतना भी ज़्यादा नहीं है winters में, यो clouds बनेगा ऊपर जाएगा. There will be fog, and fog is so tiny and so हल्का that it is so light कि air उसका वजन उठा सकती है, and therefore water vapor will remain in suspension. They will not fall down as precipitation. They will remain in suspension, and we have fogs. If there is any dead object or abiotic component such as stone, and this stone will become so cool that water droplets, if there is a water droplet in the atmosphere, obviously 75% के आसपास humidity होती है, this due to cooling water droplets will get accumulated on the stones etc., and this will result into formation of dew. Fine. And thirdly, कभी कभी इतना ज़्यादा cold होता है कि instead of water droplets यहाँ पे there is accumulation of ice, and this is what is known as frost. So understanding importance of temperature inversion in meteorology, it results into formation of fog, dew and frost. और इस साल prelims में ये question आया था, sometimes dew does not form during which condition? One option was presence of clouds in the sky. Why? That was the right answer, because the clouds is going to reflect it. Fine. ये wrong नहीं करना है ये सब answers prelims में भी, because जहाँ तक अभी मैंने कहा आपको ये सब हम GS में as it is पढ़ते हैं. What is different in optional is upper air inversion. Upper air inversion, ground is there, air becomes very hot, air rises upwards, and after going upwards for 3 kilometers, it will become very, very cool. Fine? It will become very cool. नीचे का environment is warmer. This cool air will then, because of higher density, will subside और वो नीचे आएगा, pushing the warm air which is lighter upwards. So it will result into, ultimately the final result will be ऊपर warm air चली जाएगी, नीचे cold air रहेगी. बन गया temperature inversion. कहाँ पे? In the, not near the ground. कहाँ पे? In the upper atmosphere. Very easy topic. Getting it? Obviously I will tell you what is this in detail. We will be writing this in detail. Fine? So temperature inversion in meteorology, temperature inversion in meteorology is the process in which the vertical distribution of air is affected, the vertical distribution of temperature is affected, not air. The vertical distribution of temperature is affected. In the normal conditions, the temperature decreases with increasing height, temperature decreases with increasing height, full stop. But in some circumstances, the warm air lies above the cold air. The warm air lies above the cold air, causing negative lapse rate. Such phenomena is known as temperature inversion. Causing negative lapse rate. Such phenomena is known as temperature inversion. And a common diagram which we had drawn that day, that is, in the normal condition, the temperature will go on reducing. In some conditions, the temperature initially reduces, then increases, and then reduces. So this is the inversion layer or zone. This is the condition of temperature inversion. This is the normal phenomena. नीचे temperature, ऊपर height. Understood? Basically, there are three types of temperature inversion. One is non-advectional, no movement of air. One is advectional, naturally there is a movement of air. Third is forced, जिसको हम कहेंगे mechanical inversion. Fine? So the three types of temperature inversion are non-advectional, advectional, and mechanical. Understanding? Advectional matlab when there is a movement of air. कैसे? देखो, advection, convection. Convection is vertical, advection is horizontal. So wind is advection, horizontal movement of air. We'll start with the non-advectional inversion. Now, how are the questions? Questions are generally asking you about the radiation inversion. Yeah, question will directly come on the temperature inversion. When the question comes on the temperature inversion, write whatever it is, but compulsory starting में this diagram and definition should come. Negative lapse rate is the most important word in this. Fine? And this diagram, general diagram should come. Then depending upon kabhi short note on the ground inversion, kabhi short note on the non-advectional inversion, kabhi write a short note on upper air inversion, whatever is asked. Fine? And kabhi what is the significance? पिछले साल ये same question was in GS. What do you understand by the temperature inversion in meteorology and examine उसका significance? GS में ये सब मत लिखो, mechanical हो सब. GS में सिर्फ example लिखो, non-advectional मतलब क्या, advectional मतलब क्या, ground inversion in non-advectional, valley inversion in advectional, and उसका significance fog case से problems क्या, dew से problems क्या, frost case से problems क्या. Don't make your answer too technical in GS. मीन्स ये अपर एयर इन्वर्जन, सबसिडेंस इन्वर्जन, ये सब बिल्कुल मत लिखना जीएस में, अदरवाइज एक तो यू वोंट बी एबल टू डू जस्टिस टू द क्वेश्चन, बिकॉज जीएस में सिर्फ टेम्परेचर इन्वर्जन नहीं, उसके इम्पैक्ट्स भी पूछेंगे। ऑप्शनल में एक ही कंसेप्ट को बहुत डिटेल में पूछेंगे, फाइन, एज इट इज द क्वेश्चन केम इन लास्ट ईयर्स जीएस आल्सो। So when we do this, you will find numerous questions in climate coming as it is in GS. You will find same with geography paper 2 also. Non-advectional inversion are of two types. We are going to study सबसे पहले ground inversion. और radiation inversion. And the second is upper air inversion. यहाँ पे also there is an upper air inversion. Advectional inversion में there also is an upper air inversion. But the difference is यहाँ पे there will be movement of air, यहाँ पे there will be no movement of air. Fine. So initially ground inversion. Those who have studied in GS, tell me क्या क्या है ये ground inversion. सबसे पहले what happens? क्यों? लैंड के कांटेक्ट में आके एयर कूल होती है, उसके बाद एयर ऊपर जाती है, नहीं जाती, एयर वहीं रहती है, ऊपर की एयर वार्म रहती है, ऊपर की एयर वार्म एयर नीचे आ सकेगी, नहीं आएगी। क्यों? एयर नीचे से वार्म, ऊपर की वार्म एयर नीचे क्यों नहीं आएगी? बिकॉज इफ द एयर इज वार्म अबव एंड कोल्ड बिलो, then warm air does not have power to displace the cold air. But if there is a cold air below and warm air above, the cold air being denser has power to displace the warm air. Warm air can always be moved by the cold air. Cold air can never, warm air can always be moved by the cold air. Cold air can never be moved or displaced by the warm air. बस ये facts याद रखो, पूरा fronts, temperate cyclones are very easy. Climate is very easy. Fine. So whatever this diagram I had drawn and the four conditions, this is what is known as ground inversion. Why ground inversion? Because it occurs near the ground. कहाँ पे होता है? ज़्यादा से ज़्यादा 200 मीटर फ्रॉम द ग्राउंड या 500 मीटर फ्रॉम द ग्राउंड. एंड इसीलिए ये कब होने वाला है? इन द कमिंग मंथ्स इन दिल्ली. इसीलिए यू विल सी फॉग्स कमिंग इन दिल्ली. Very near to the ground. This occurs very near. The air which is in immediate contact with the ground is cold. उसके just ऊपर की air, maybe first floor के ऊपर air is warm. उसके ऊपर की air is warm. उसके ऊपर की air is more warmer. So पूरे इस region में condensation होते जाएगा and there will be the formation of fogs. Getting it? Second divide is known as radiation inversion because the ground is losing the heat at the night time by the giving out terrestrial radiation, and therefore it is known as a radiation inversion. So what are the four conditions? These are the four conditions. Commonly asked question in prelims. इस साल इसी क्वेश्चन को थोड़ा मॉडिफाई किया और उसका इम्पैक्ट पूछा. एंड मेंस में यू जस्ट हैव टू एक्सप्लेन why it is known as non-advectional inversion. And lastly, you have to explain the world distribution of this in optional. Fine. So ground inversion. Such inversion occurs near the Earth's surface. Such inversion occurs near the Earth's surface due to the mechanism of radiation. Due to the mechanism of radiation, and hence also known as radiation inversion. hence also known as radiation inversion. Such inversion occurs in static atmosphere. Such inversion occurs in the static atmosphere, and hence is an example of non-advectional inversion. Hence is an example of non-advectional inversion. Mechanism. During winters, अब winters में winds ज़्यादा होती है या कम होती है? Tell me your past experiences. Are there more winds during the winters या less winds? Why? Why less? Why someone said more? Why more? Winters में air is very dense. Because the air is very dense, more frictional force, so it is unable to move. This can be one reason. Second reason is winters are characterized by high pressure. High pressure में there is a subsidence of air. Subsidence means ऊपर से air धीरे धीरे नीचे आएगी, and as a result subsidence में कभी भी winds नहीं होगा. Winds will always be in the low pressure condition, so that high pressure कहीं दूर, at some other place there is a high pressure, it will attract the winds. So याद रखना conceptually, cold wind is always denser, therefore more frictional force and more gravitational force. Gravitational force अभी आपको दिख रहा है AC में, the cold air is being pulled downwards because of more denser. Frictional force अभी आपको दिखेगा आगे वाले seasons में कि winds, there will be no winds, no movement of air in Delhi, पत्ते ऐसे ही रहेंगे, and इसी के कारण pollution भी वैसे ही रहेगा. If there is movement of air, pollution is diffused, removed from the region. But winters में pollutants stay in this region, and hence Delhi में smog, fog, problems, air pollution will increase. So where was I? During winters, the cold denser air, underline the word cold denser air, comes into the contact with the cold ground or snow covered ground, comes into the contact of cold ground or snow covered ground, full stop. The ground is cold due to excessive nocturnal cooling. Understanding excessive nocturnal cooling means night time cooling, excessive nocturnal cooling, and rapid loss of terrestrial radiation. See, those who attended my GS class, concept वही है, but language देखो change हो गई. Understanding optional है ये. So you have to mention terrestrial radiation, you have to mention nocturnal cooling. नहीं तो GS में हम क्या लिखते हैं? Cold ground surface. बस बात खत्म. Excessive loss of terrestrial radiation. Full stop. Consequently, the layer of the air just above the ground becomes cold. The layer of the air just above the grounds become cold, while the upper layer remains relatively warmer. While the upper layer remains relatively warmer. Such kind of inversion is ground inversion. Such kind of inversion is ground inversion. Conditions 1. conditions 1. Long cold winter nights, long cold winter nights, so that loss of terrestrial radiation exceeds incoming solar radiation, Point number 2, condition 2. Cloudless and clear skies, so that the terrestrial radiation is lost inside in the space, without any obstruction, because the clouds if present will reflect the terrestrial radiation. Point number 3, presence of dry air near the ground, so that it does not absorb the radiant heat, and lastly, no or very less movement of wind, so that there is no mixing up of warm and cold layers. Next point, such temperature inversion is present throughout the year in polar regions, but in the middle latitudes, it occurs only during the winter season. Yes, winters. So what? In the highland region, there will be valley inversion. In the ground inversion won't occur, but valley inversion will be there. Your question is temperature inversion, will it occur? Yes. Ground inversion will not occur. Ground inversion will never occur in equatorial region. Still Kerala has fogs in Munnar. Why? Valley inversion. And this is the diagram. जस्ट हमें इस डायग्राम में दिखाना है कि 1 किलोमीटर के लेयर तक ही सबसे ज़्यादा इन्वर्शन है. Clear? Next point, ground inversion generally disappears with sunrise, Such inversion, full stop के बाद, such inversion promotes atmospheric stability, मतलब एयर ऊपर नीचे नहीं जा रही है, promotes atmospheric stability, comma fog, dew and frost in lower atmosphere. Atmospheric stability कहाँ, lower या upper? Lower atmosphere. Why we say atmospheric stability? Done with this diagram. Suppose if there is a warm air here instead of the cold air, what will happen? This warm air will start rising upwards by the process of convection, and then it will result into formation of clouds and maybe rainfall. So this we will call it as an atmospheric instability. Clear? Now the second kind of inversion which is important is upper air inversion. Don't write till I ask you to, means first try to understand this. The upper air inversion is thermal upper air inversion or it is mechanical upper air inversion. Mechanical upper air inversion obviously will come in this, but मैं साथ साथ ही आपको पढ़ाऊंगा. It should basically come in this part, upper part. Now what is the thermal upper air inversion? In the stratosphere, as we go up, the temperature should go on decreasing or increasing. As we go up, general temperature should go on decreasing. But sometimes in the stratosphere and upper troposphere, there is a dominance of ozone. Ozone permanent नहीं है, ozone बनता है, कम होता है, naturally also. Ozone is caused due to a reaction. जितने ज़्यादा UV rays, उतना ज़्यादा oxygen will break down to form ozone. Ozone का formation depends upon how much other catalysts are there. मतलब कितना chlorine है, कितना nitrous oxides है, and this keeps on changing with the UV rays, with the seasons, etc. So sometimes when there is too much large amount of ozone, it is going to absorb all the UV radiations, and therefore this entire region will become very, very warm. But नीचे का region will be basically cold of the troposphere. कौन सा inversion हो गया ये? Upper air inversion. It has nothing to do with the ground. It has to do with the boundary of tropopause and stratosphere. So this is what is the upper air inversion, what we will call it as a thermal upper air inversion. Fine. अब देखो, कभी-कभी when you know too much of many things, you find sometimes the questions are confusing. For example, GS में, prelims में भी ये 2 बार आया है that the temperature inversion is largely limited to the troposphere. True or false? True. अब जो ऑप्शनल के स्टूडेंट्स हैं वो कभी-कभी ज़्यादा दिमाग लगाते हैं, नहीं हमने तो स्ट्रेटोस्फेरिक इन्वर्जन की भी बात कही थी, हमने पढ़ा था. सो ऐसे समय जीएस में बहुत ज़्यादा दिमाग मत लगाना. फाइन. और फिर हम इजी क्वेश्चंस को भी ज़्यादा दिमाग लगा के रॉन्ग करके आते हैं, और एक किसी भी ऑप्शनल वालों के साथ होता है. पॉल साइंस वाला या पब्लिक एडमिनिस्ट्रेशन वाला ज़्यादा दिमाग लगाएगा इन द पॉलिटी. रिमेंबर जीएस का स्टडीज इज़ वेरी डिफरेंट एंड ऑप्शनल का इज़ वेरी डिफरेंट. You know about stratospheric inversion, but ये exceptional cases है. But generally tropospheric inversion ही होता है. There is no inversion in the stratosphere. This is only one exception. कि whenever there is a ozone, it will trap the UV rays. So remember for this mistakes and read the question again. Question UPSC ने पूछा है, generally the temperature inversion is limited to the troposphere. हाँ, generally, because even if you do the optional very properly, हम सारा tropospheric inversion ही करेंगे except for one inversion, that is this stratospheric inversion. Getting it? So next point, The thermal upper air inversion, the thermal upper air inversion is caused due to the presence of ozone between the height of 15 to 35 kilometers. Presence of ozone between the height of 15 to 35 kilometers. This ozone layer absorbs most of the ultraviolet radiations. This ozone layer absorbs most of the ultraviolet radiations, and therefore the temperature of this layer becomes much higher than the airs lying above as well as below it. The temperature of this layer becomes much higher than the temperature of the air lying above and below it. Above and below it. Causing upper air inversion. Causing upper air inversion. Causing upper air inversion. Such temperature inversion occurs. Such temperature inversion occurs only when there is no vertical movement of air. Only when there is no vertical movement of air. There is no diagram for this. This diagram is just for your understanding. Why only when there is no vertical movement of air? Because if there is vertical movement of air, there will be mixing. Mixing say this layer will be removed. Fine? So what is temperature inversion? एक बेसिक, ऊपर कैसी एयर होनी चाहिए? Warm. And नीचे कैसी एयर होनी चाहिए? Cold. So in general this region is very very warm. Fine, and जैसे हम ऊपर जाएंगे this region becomes very cold. Understanding? But during the summer season sometimes there is huge amount of insolation and therefore low pressure systems develop. Getting it? As the low pressure system develops, because the heat is trapped, the air from this region starts rising upwards. And see the diagram हम हमेशा ऐसे बनाते हैं because ऊपर जाके air will expand. Air, और आपको दिखता भी है air is expanding because density decreases. As the air expands, it cools. As the air cools, तो ये normal है. Fine? अब sometimes during the extreme summer season, the warm air is being thrown upwards with very very high speed. जितनी नीचे ज़्यादा गर्मी है, उतना stronger is the low pressure and उतना vertical the rise of the air is. So this warm air which goes, it sometimes goes up to such a greater height कि यहाँ पे this region becomes warm. Naturally this region has a cold air, but due to tufan, andi, etc., the warm air is thrown upwards, and when it is thrown upwards, it sometimes goes to such a greater height कि नीचे का air remains colder. Understanding? Such kind of an inversion. For example, again, low pressure belt है, the warm air is rising upwards, and once it rises upwards vertically, it settles in this region. Even though it has settled in this region, यहाँ पे the temperature of this air is comparatively warmer as compared to the temperature of the air which is below, cold, naturally. So this is upper air inversion या ground inversion? What is this? Upper air inversion or a ground inversion? Upper air inversion. It is not ground inversion. कहाँ पे ground के पास? And this upper air inversion is caused due to movement of air or no movement of air? Movement of air. This inversion is what is known as मैकेनिकल अपर एयर इन्वर्जन. सो व्हाट इज मैकेनिकल अपर एयर इन्वर्जन? सिंपल लैंग्वेज में किसी को दिखाना है कि देख, नॉर्मली नीचे देयर इज अ वार्म एयर, ऊपर देयर इज अ कोल्ड एयर, बट समटाइम्स ड्यू टू एक्सट्रीम इंसोलेशन देयर इज अ लो प्रेशर सिस्टम डेवलप्स. Because of this there are thunderstorms, cyclones, etc. This cyclonic storms transport the warm air upwards, and when it goes upwards sometimes it goes to such a greater height कि surrounding air is cold, but that region जहाँ पे air रुक जाती है that remains warm. So नीचे की air is colder, ऊपर की air remains warm, resulting into upper air inversion. Such kind of upper air inversion is known as mechanical inversion. Clear? Understanding everyone? Understanding or not? No? एयर ऊपर जा रही है, कोल्ड ही हो रही है, बट जब हम टेम्परेचर इन्वर्जन करते हैं इन दोनों की रिलेटिव टेम्परेचर्स की बात कर रहे हैं, वो इतनी कोल्ड नहीं होती कि इट मैचेस विद द सराउंडिंग एयर. इफ यू हैव नॉट अंडरस्टूड, all is troposphere. I am just using very crude, exact वो नहीं है, but 6.5 से मैंने माइनस किया. 30 डिग्री सेल्सियस, 1 किलोमीटर बाद देर इज 23, मे बी यहाँ पे 18 डिग्री सेल्सियस, यहाँ पे 11 डिग्री सेल्सियस, 18 नहीं, चलो अंडरस्टैंडिंग इट, यहाँ पे 5.5 डिग्री सेल्सियस एट सर्टन हाइट. दिस इज द टेम्परेचर ऑफ द सराउंडिंग एयर. नाउ यहाँ पे है सिटी, मे बी यहाँ पे कॉन्क्रीट है, एंड देयरफॉर कॉन्क्रीट इज ट्रैपिंग मोर हीट. As the concrete is trapping more heat, low pressure system develops. Low pressure system के कारण this air is thrown upwards. This air which goes upwards, it is cooling at the rate of maybe dry adiabatic lapse rate या wet adiabatic lapse rate, किसी से भी. When this air goes upwards, यहाँ पे आने के बाद this air का temperature is around 7 डिग्री सेल्सियस. बट व्हाट इज द टेम्परेचर ऑफ द सराउंडिंग एयर? यहाँ पे 5.5 डिग्री सेल्सियस. क्यों इसका टेम्परेचर ज़्यादा है? डिपेंड्स अपॉन द ग्राउंड कंडीशंस. मे बी इस एरिया में टेम्परेचर वॉज 40 डिग्री सेल्सियस बिकॉज ऑफ कॉन्क्रीट, बिकॉज ऑफ एयर कंडीशंस और मेनी रीजन्स. ऊपर जाके इस एयर का टेम्परेचर बन गया 7 डिग्री सेल्सियस. सो व्हाट यू विल कॉल दिस एयर एज वार्म and relatively this air as cold. हो गया टेम्परेचर इन्वर्जन. नहीं तो इसके ऊपर की एयर का टेम्परेचर शुड हैव बीन मे बी लेस 3 डिग्री सेल्सियस, बट इसका टेम्परेचर इज ग्रेटर 7 डिग्री सेल्सियस एज कंपेयर टू द सराउंडिंग रीजन जहाँ पे टेम्परेचर इज 5.5 डिग्री सेल्सियस. क्यों? बिकॉज द एयर वॉज फोर्स टू गो अप. सो व्हेन एनीथिंग ऑकर्स ड्यू टू फोर्स, इट इज नोन इन क्लाइमेटोलॉजी एज मैकेनिकल. For example, when air is forced to go up due to a mountain barrier, it is known as mechanical instability. यहाँ पे the air is being forced to go up due to certain conditions on the ground, and इसीलिए बाद में temperature inversion हुआ. So this is what is known as mechanical temperature inversion. Now understood? Understanding? क्यों एयर ऊपर जा सकती है? इसके बहुत रीजंस है, उसके बारे में आप टेंशन मत लो. उसका साइक्लोन कैन बी रीजन, उसका आंधी कैन बी रीजन, उसका नीचे में भी किसी ने जला दिया, उसका फॉरेस्ट फायर्स कैन बी रीजन. देयर कैन बी न्यूमरस रीजंस. एयर ऊपर जाएगी ड्यू टू हीटिंग. ऊपर जाते जाते वो कूल हो रही है, पर इतना कूल नहीं हुई कि इसका टेम्परेचर इज लेस देन द सराउंडिंग एटमॉस्फेयर. सो इट रिमेन्स वार्म, एंड वार्म होने के कारण वो फिर से नीचे आएगी नहीं. So we say temperature inversion will always promote atmospheric stability. Fine? Now understood? So mechanical inversion. mechanical inversion of temperature is caused at higher heights. Higher heights in the atmosphere due to turbulence and convective mechanism. Due to turbulence and convective mechanism. It is generally caused due to, it is generally caused, दो conditions है. It is generally caused due to, condition 1, condition 1. Sometimes the warm air is suddenly transported upwards. Sometimes the warm air is suddenly transported upwards. Warm air is suddenly transported upwards. Up to a greater heights. Up to a greater heights. Into the regions of cold air. Into the zone of cold air. The temperature of this transported air does not decrease as rapidly as environmental lapse rate. The temperature of this transported air does not decrease as rapidly as environmental lapse rate. कब हो सकता है? Very simple. What is the environmental lapse rate? 6.5 degrees Celsius per kilometer. What is the wet adiabatic lapse rate? 5.5 to 6 degrees Celsius per kilometer. So जैसे if the air is going upwards by the wet adiabatic lapse rate, moist air, यहाँ पे आने के बाद the environmental lapse rate 30 minus 6.5 is 23.5. और ये एयर जो ऊपर जा रही है 30 minus 5.5, इसका टेम्परेचर विल बी 24.5, which is more colder surrounding air, environment. ये more warmer है. हो गया टेम्परेचर इन्वर्शन. Fine. So where did I stop? May not cool as compared to the as environmental lapse rate, and therefore such air remains warm than the surrounding air mass. Such air remains warm than the surrounding air mass, causing temperature inversion. Causing temperature inversion. Causing temperature inversion. Condition 2. Sometimes the air descends and warms air descends and warms by dry adiabatic lapse rate. By dry adiabatic lapse rate of 10 degrees Celsius per kilometer. Of 10 degrees Celsius per kilometer. Degrees Celsius per kilometer. This descending air because of warming, this descending air because of warming, experiences higher temperature than the surrounding air. Causing temperature inversion. Than the surrounding air, causing temperature inversion. Read this statement again and tell me whether you have understood or not. See, there is a presence of an anticyclone या high pressure here. High pressure में हमेशा air नीचे आएगा. जब air नीचे आएगा तो it has two choices. If it is dry air, it will get warmed at the rate of 10 degrees Celsius per kilometer. If it is a wet air, it will get warmed at the rate of 5.5 degrees Celsius per kilometer. Right? When the static environment is there, when you come down, environment is getting warmed at the rate of 6.5 degrees Celsius per kilometer. Air जब नीचे आ रहा है तो it is getting warmed either by dry or wet adiabatic lapse rate. ये कल समझ में आया? Now this air is coming down and it is getting warmed at the dry adiabatic lapse rate. मतलब for every kilometer it is उसका temperature is increasing by 10 degrees Celsius. And 1 kilometer बाद, that is maybe after 1 kilometer, the temperature of this region should be 6.5 degrees Celsius. Because वहाँ पे temperature is 0 degrees Celsius. But जब air नीचे आता है, इसका temperature becomes 10 degrees Celsius. Understanding? Why? Because it is getting warmed at the dry adiabatic lapse rate. हो गया temperature inversion? हुआ कि नहीं temperature inversion? This is also mechanical inversion. This is the line. Again, height. I will show you some other method now to come to this conclusion. 1 kilometer, 2 kilometers. There is a parcel of air at 2 kilometers, जिसका temperature is, take any 5 degrees Celsius. Fine? यहाँ पे after 1 kilometer the temperature of this entire region should be 5 plus 6.5. कितना? 11.5 degrees Celsius. At the ground this should be 11.5 plus 6.5. That is 16 कैसे? 17 degrees Celsius. Due to some conditions, an anticyclone develops here. High pressure zone develops in this entire region. Environment, अब anticyclone है तो air ऊपर नीचे हो रही है. The air is going to come and up and down, not the static environment. And air, when it comes up and down, remember yesterday, air will never follow the rule of dry and the environmental lapse rate. Air will come either by the dry adiabatic lapse rate or wet adiabatic lapse rate. Now take a certain condition, air is coming downwards at the wet adiabatic lapse rate. So uska temperature of this air will become 5 plus 5.5, kitna? 10.5 degree Celsius. It is coming down at wet adiabatic lapse rate, uska temperature becomes 10.5 degrees Celsius. The temperature of surrounding air is 11.5. Is it temperature inversion? No. Because the नीचे की air comparatively warmer है 11.5 degree Celsius पे, ऊपर की air is comparatively cooler at 10.5 degree Celsius. But if the air is coming down at dry adiabatic lapse rate, 1 किलोमीटर बाद उसका टेम्परेचर इज गोइंग टू इंक्रीज बाय 10 डिग्री सेल्सियस. सो 1 किलोमीटर बाद ये एयर का टेम्परेचर विल बी 5 + 10 दैट इज 15 डिग्री सेल्सियस. द टेम्परेचर ऑफ सराउंडिंग एयर इस पूरे रीजन में 11.5, 11, 10, 15 तो होगा ही नहीं. सो दिस उसका टेम्परेचर विल बी मे बी will take थोड़ा नीचे, the temperature will be 10 डिग्री सेल्सियस. क्या हुआ है? टेम्परेचर इन्वर्जन. क्यों हुआ है? ड्यू टू फोर्स्ड अपलिफ्ट? नहीं, ड्यू टू सब्सिडेंस. सब्सिडेंस एट व्हाट रेट? ड्राई एडियाबैटिक लैप्स रेट. सो मैकेनिकल इन्वर्जन इज ऑफ 2 टाइप्स. थोड़ा टफ है ये. मैकेनिकल इन्वर्जन इज ऑफ 2 टाइप्स. अपर एयर इन्वर्जन इज ऑफ 3 टाइप्स. वन अपर एयर इन्वर्जन जो स्टैटिक एयर में होता है ड्यू टू ओजोन, थर्मल अपर एयर इन्वर्जन एंड मैकेनिकल इन्वर्जन. मैकेनिकल इन्वर्जन इज ऑफ 2 टाइप्स. कन्वेक्टिव अपलिफ्टिंग या ड्यू टू सब्सिडेंस एट ड्राई adiabatic lapse rate. And therefore read the statement now again. Sometimes air descends and warms by dry adiabatic lapse rate of 10 degrees Celsius per kilometer. This descending air, because of warming, experiences higher temperature than the surrounding air, causing temperature inversion. Understanding this? Now? Fine? Such conditions occur in anticyclonic conditions. Such conditions occur, or such situation occurs in anticyclonic conditions. In anticyclonic conditions. मतलब whenever there is anticyclone. And cyclone means low pressure. Anticyclone always means high pressure. High pressure means air नीचे आएगा. एंटीसाइक्लोन्स हमेशा डेवलप होंगे इन मिडल लैटिट्यूड्स. लो प्रेशर हमेशा होगा नियर द इन द ट्रॉपिक्स जहां गर्मी है. एंटीसाइक्लोन हमेशा होंगे ईदर बिटवीन 30 to 35 डिग्री नॉर्थ एंड साउथ और बिटवीन इन द पोलर रीजन्स. फाइन. सो सच कंडीशंस आर वेरी कॉमन in the regions of high pressure. Such conditions are very common in the regions of high pressure, where air is forced to sink, where the air is forced to sink. That is in the subtropical high pressure belt, in the subtropical high pressure belt, or in the polar high pressure belt, or in the polar high pressure belt. In the subtropical high pressure belt or the polar high pressure belt. And you can draw this diagram. look at the diagram very properly, I have contracted the air parcel A. Examiner will understand what you have to say. It's coming down at dry adiabatic lab side, उसका यहाँ पे temperature has become 10 degree Celsius, यहाँ पे temperature has become plus 20 degree Celsius, हो गया temperature inversion. For your understanding, I have made it more simple. आप पहले इस पे भी रोक सकते हो, right? Just make sure that you show that the air parcel is contracting. Getting it? Can I continue? Such temperature inversion मतलब कौन सा? Subsidence inversion is more prominent in the summer seasons, in the winter seasons. Is more prominent in the winter seasons. And therefore it is associated with cyclonic activities, anticyclonic activities in the middle latitudes. It is associated with anticyclonic activities in the middle latitudes. Associated with the anticyclonic activities in the middle latitudes. See, कहाँ पे होता है ये temperature inversion? No need of drawing this diagram. Let's just see here. Ground, equator, 0 to 10 degree. It is hot. यहाँ से the air is forced to rise up. Trade winds, we call it as ITCZ. After reaching around 18 kilometers near the ground, it gets bifurcated. एंड वो जाता है नदर्न हेमिस्फीयर एंड सदर्न हेमिस्फीयर में. ऊपर जाके वो ठंडा हो जाता है इसलिए डेंसर, और फिर वो नीचे आना शुरू हो जाता है. कहाँ पे? समवेयर बिटवीन 30 to 35 डिग्री लैटिट्यूड्स. ये है द जोन ऑफ सबसिडेंस इन्वर्शन. सिमिलरली cold polar easterlies, this wind starts from the poles. After reaching around 60 to 65 degree latitudes, polar region is more colder as compared to 60 to 65 degree latitude, so this wind becomes more warmer. When it comes to lower latitudes, ये ऊपर जाती है, and then it bifurcates and फिर से यहाँ नीचे आना शुरू हो जाती है. Zone of subsidence inversion. That is what we have written. It occurs in the between these two regions. No need of this diagram. Fine. So understood what is the mechanical inversion? अगर कल क्वेश्चन आता है अपर एयर इन्वर्जन, which is the commonly asked question, you have to write all three. If कल क्वेश्चन आता है regarding the mechanical inversion, you have to just write this part. and draw this diagrams. You will find such similar diagrams in Savindra Singh. Baki ka is formality, GS only, that is advectional inversion caused due to movement of air. So advectional inversion is also known as dynamic inversion. Is also known as dynamic inversion, and it is caused due to either horizontal or vertical movement of the air. देखो ये exception है, वैसे advection means only horizontal movement of the air. It is caused due to either horizontal or vertical movement of the air. It is caused due to either horizontal or vertical movement of the air. Means advectional inversion में हम vertical movement of the air भी consider कर रहे हैं. But remember, then why don't we call this as a convectional inversion? Because in this vertical movement of the air is not straight upwards, थोड़ा बहुत vertical. मतलब if this is a mountain, तो as per the slopes, winds will come down. We cannot call this as neither as horizontal, neither as vertical. So we will call this as a advectional, जहाँ पे there is a movement of the wind. Wind generally means horizontal, but अगर mountain है तो obviously wind will be forced to rise up, come down. So caused due to the horizontal and vertical movement of the air. Why it is known as dynamic inversion? Because वहाँ पे there is a movement of a air. It is further divided into first surface inversion. We'll do the surface inversion. Further divided into surface inversion. Air above the warm Gulf Stream will be warm. Air above the cold Labrador current will be cold. Fine? Cold ocean के ऊपर की, this air will move in this direction, this air will move in this direction. When they both mix, it results into inversion. Ground inversion only, but it is caused due to the movement of the air, not due to the stagnation of the air. Stagnation of the air तो उसको हम कहेंगे ground inversion, इसको हम कहेंगे surface inversion. So can I say surface? और या ये एक example. दूसरा example, air from the polar region comes to the tropics, air from the tropical region goes to the subtropics, दोनों बीच में मिलती है, mix हो जाती है, results into inversion. Cold air and warm air, whenever it will mix, cold air being denser will come downwards, warm air will go upwards. हो गया temperature inversion? Because normal condition means what? Warm air should be below, cold air should be up. But temperature inversion में exactly opposite. So surface inversion means inversion that is caused by horizontal movement of the air. And ocean currents का inversion, which is the strongest zone of temperature inversion in the world. Because जितना ज़्यादा temperature difference ज़्यादा, जितना greater is the temperature gradient, उतना stronger is the fog. जितना cold is the water inside this glass, उतना outside there will be droplets. That is what is the fog. जितना the temperature difference. So the greatest temperature difference कहाँ पे हो सकता है? Tropics के water के ऊपर और poles के water के ऊपर. And therefore this is the most densest fogs in the world, which are caused due to the mixing up of warm and cold ocean currents. Fine? And resulting into temperature inversion. Getting it? Surface inversion. So surface inversion is caused due to horizontal movement of air horizontal movement of the air when warm and cold air masses when the warm and the cold air masses mix due to several reasons such as convergence of ocean currents the warm air being lighter rises upwards and the dense colder air descends causing temperature inversion. Such type of temperature inversion is most commonly seen in the regions of mixing of warm and cold ocean currents. And therefore, these regions are the regions of most dense fogs in the world. These regions are the regions of most dense fogs in the world. You already know this example. Icebergs लेके आ रहा है, so obviously this is extremely cold air. What is this region known as? जहाँ पे दो important islands हैं. ये सब एक्स्ट्रा जीएस के लिए, यहाँ पे ज़रूरत नहीं है. Newfoundland and Nova Scotia. This is the richest fishing region in the world. Mixing of ocean currents. सारा phytoplankton Gulf Stream will take there. सारा dissolved oxygen वाला dense water it will bring here. So the phytoplanktons will grow more. Hence it will attract the fish. And obviously we know that यहाँ पे there is a very very wide continental shelf. Next, frontal inversion. Frontal inversion. Frontal inversion. What is a frontal inversion? सबसे पहले what is front? What is a front in geography? What is a front in general English? Front मतलब battle front, जहाँ पे two enemies stand face to face with each other. So in geography, just remember. (30° to 35° north. डायग्राम की ज़रूरत नहीं. 60° to 65° north, 90°. This is the region जहाँ से extremely cold air will originate, and this is what is known as polar easterlies. Due to the Coriolis force, they will get deflected to the right. This is the region of warm westerlies. Due to the Coriolis force, they will get deflected to their right. यहाँ पे right is this, यहाँ पे right is this, and therefore the cold and warm air will mix. जहाँ cold and warm air is going to mix, the region जहाँ पे the cold air will come down and warm air will go upwards. So this sloping boundary जहाँ से the cold air is coming down and the warm air is going upwards is what is known as fronts. Fine. So fronts occur when there is a convergence of two contrasting air masses, मतलब warm westerlies and cold easterlies between 60 to 65° latitude. So this is nothing but a temperate cyclone. So frontal inversion occurs in the regions of temperate cyclone. So frontal inversion, it occurs in the temperate zones of the world. In the temperate zones of the world, due to the mixing up of warm westerly winds and cold polar easterly winds. Warm westerly winds and cold polar easterly winds. This inversion gives rise to the formation of fronts. This inversion gives rise to the formation of fronts. Full stop. Front is a sloping boundary. Along which the warm air rises upwards Next point, इट इज़ इम्पॉर्टेंट टू रिमेंबर, मतलब ये आपके लिए कह रहा हूँ मैं, इट इज़ इम्पॉर्टेंट टू रिमेंबर, ये पॉइंट आना ही चाहिए. दैट इज इन द फ्रंटल इन्वर्जन्स, इन द फ्रंटल इन्वर्जन, as the warm air rises upwards, as the warm air rises upwards, the moisture content increases, the moisture content increases, which results into condensation and precipitation, which results into condensation and precipitation. See, कोई भी क्वेश्चन अगर जो हमने अभी तक फ्रंट्स नहीं किया है, पर इसका मतलब ये नहीं है कि एग्जाम में आप आंसर प्रॉपरली नहीं लिखोगे. सो इस आंसर में आने दो ये दो डायग्राम्स ऑफ वार्म फ्रंट एंड द कोल्ड फ्रंट, because you will have to, answer will obviously be holistic, you will not be waiting for, then when I will tell you this things, you will understand why this figure is like this. Can you see, one is very gentle, warm front, one is very steep, that is the cold front. दोनों में गर्म हवाई ऊपर जा रही है. What is the other important thing you should remember is, unlike any other inversion, frontal inversion में बारिश होने वाली है. So ये मत लिखना frontal inversion के बाद कि it causes atmospheric stability. इसलिए मैंने कहा था moisture level increases and precipitation होगा. इसमें जैसे हवा ऊपर जाएगी, there will be formation of clouds and rainfall. इसमें जैसे हवा ऊपर जाएगी, there will be formation of cumulonimbus clouds and very heavy rainfall. ये जो है ये हवा ऐसे ऊपर जा रही है, एंड बेसिकली इन दिस क्लाइमेटोलॉजी इतना सब बनाने की ज़रूरत नहीं एग्जाम में. दिस इज व्हाट इज नोन एज टॉर्नेडो. टॉर्नेडो ऑलवेज ऑकर्स इन द वार्म फ्रंट. ये जब दोनों डायग्राम इकट्ठा हो जाएंगे, इसी को हम कहेंगे टेम्परेट साइक्लोन. फाइन. सो फ्रंटल इन्वर्जन इज द रीजन ऑफ टेम्परेट साइक्लोन्स. गेटिंग इट? नेक्स्ट लास्ट पॉइंट, फ्रंटल इन्वर्जन. Frontal inversion is important for rainfall or precipitation. Frontal inversion is important for rainfall or precipitation. जो लिखना है वो लिखो, दोनों मत लिखो. In the middle latitudes, in the middle latitudes, in India, the rainfall from the frontal inversion is known as western disturbances. In India, the rainfall from the frontal inversion is known as western disturbances. सो बारिश जो आती है विंटर्स में, वो क्यों आती है? ड्यू टू फ्रंटल इन्वर्शन. is known as western disturbances. And the last is valley inversion, very easy. During the night time, imagine this is a mountain, this is a mountain, this is a valley. During the night time, slopes of a mountain, valley floors, slopes of a mountain. So रात में this part will lose the heat very quickly to the atmosphere क्योंकि density कम है, clouds नहीं है, ऊपर की air less denser है, water vapor कम है. So यहाँ का parts, that is the upper parts of the mountains. This diagram is nothing but understanding. So the upper part of the mountain will lose the heat very quickly to the surroundings during night time, and therefore यहाँ पे क्या होगा? Cold and high pressure. Why high pressure? You will understand. नीचे का part is going to lose the heat, but it will be trapped, reflected. जो concrete करता है वैसे ही करेगा, and therefore ये गर्म रहेगा and low pressure. Normal condition है ये cold है, this is cold and this is warm. But cold air being denser, it will be pulled downwards by gravity. Fine? And the warm air will being lighter, it will rise upwards. So ultimately, क्या होगा? This region will become cold and this region will become warm, and we will call this as valley inversion. Fine? Getting it? This is what is the valley inversion. ऊपर की air becomes colder due to gravity, it is pulled downwards. जब नीचे आती है वो गर्म हवा को ऊपर फेंक देती है. So गर्म हवा ऊपर चली जाती है, नीचे cold air हो जाती है, valley में cold air इकट्ठा हो जाती है, warm air goes upwards, and we will call this as valley inversion. Getting it? Clear? So valley inversion, till the time I make a fair diagram, valley inversion occurs in the mountainous regions, due to radiation, and the vertical movement of the air. During the night time, the upper slopes of the valley will lose heat quickly. While the lower parts will be relatively warmer. And hence the cold denser air descends, occupying the valley floors and pushing the warm air upwards. Causing temperature inversion. Why it is known as advectional inversion? Because यहाँ पे there is a movement of a air. have past year questions? What happens because of this? The thing which you have already may have studied is, because of this you have studied that valley floors are avoided for human settlement, because valley floors may, after this cold air, this valley floors will have frost and extremely cold air, and therefore अगर आता है क्वेश्चन तो ही valley floors are avoided for settlements and agriculture. Because frost will destroy this thing. I have checked the past year questions. ज़्यादा तो क्वेश्चन नहीं है यहाँ से. Clear the temperature inversion. 3 है, advectional, non-advectional, mechanical. Non-advectional में ground and upper air inversion. Fine. Thermal inversion. Advectional में 3, valley inversion, frontal inversion and the surface inversion. Mechanical में upper air inversion, 2 reasons, subsidence and forced uplift. Fine? Clear? So forced uplift में the air should cool at dry adiabatic lapse rate, and in the subsidence the air should warm at dry adiabatic lapse rate. Then only environmental lapse rate से कम होगा. Fine? Now tell me what is the, I will not dictate this, significance of temperature inversion. Why is the temperature inversion important? What is the significance? Significance means क्या क्या होता है due to temperature inversion. Atmospheric stability. Stability means क्यों नीचे अगर warm air है तो warm air will always rise upwards, और cold air अगर ऊपर है तो cold air will always come downwards. This condition is instability. But in the temperature inversion, नीचे there is a cold air, ऊपर there is a warm air. So if we are here, नीचे cold air already है, वो क्यों नीचे आने की कोशिश करेगी? It will settle over there. warm air already ऊपर है, और ऊपर जाने की कोशिश क्यों करेगी? It will settle over there, and this condition is what we will call this as stability. Understanding? So the first point you should know that the temperature inversion causes atmospheric stability. In fact, you take down very fast the Temperature inversion causes atmospheric stability, which stops the vertical movement of the air. Vertical movement of the air. अब एयर ऊपर ही नहीं जाएगी तो क्लाउड्स बनेंगे. This atmospheric stability promotes dry conditions and discourages rainfall. Promotes dry conditions and discourages rainfalls. Promotes dry conditions and discourages rainfall. No need of drawing, but understand the concepts. Normal है ये, that is तब तक यहाँ पे it is very very fine. But जैसे ही cold current upwells, this region becomes cold. So the air which comes into the contact also becomes cool. And उसके बाद हो गया temperature inversion, and therefore यहाँ पे कभी बारिश नहीं होती, and we have upwelling के पास deserts. Try to understand the logic. Fine. Had there been normal condition, this in the tropics, this sea would have been very very warm, and there would have been very very heavy rainfall, and at least coastal region तो desert नहीं होता. But Atacama is a coast desert. Sahara का coastal region is desert. California is desert. Why? Because upwelling of a cold current. As the cold current upwells, the air here becomes colder. As it becomes colder, it comes in contact. The air also becomes colder, and thus promotes atmospheric stability. Past year question. Past year question. Fine. Second condition. So this past year question, what I wanted to discuss is, दो ये climatology का भी हो सकता है, oceanography का भी है, दोनों का mix है ये. Discuss the impact of ocean currents on the behavior of winds. कौन से दो example? 3 example. Mixing वाला पहले example, fine. Second upwelling वाला और ये example. Third Gulf Stream वाला और hurricanes वाला example. Fine. You put it in oceanography or you put it in climatology. Fine. Applied questions ऐसे आ रहे हैं. Specifically, the concept, the ocean currents on the air mass behavior. Air mass means nothing but wind system. And to tell you very frankly, बहुत सारे students ये question देख के डर गए थे और वो कहते क्या question पूछे. Concepts अगर पता है, ये question बहुत आसान है. किसी भी book में नहीं दिया है, ऐसे उनका common ये था. ऐसी चीजें book में देने की जरूरत नहीं है. Just have to interlink. Second, it results into formation of fogs. And fogs हम separate topic ही करेंगे. So याद रखना, fogs in the urban regions mixes with smoke to form deadly smog. Fine. When does the winter start in India? Month of November. When has Kejriwal declared odd even scheme? November. Understanding the relation? The smog ka effect to reduce the pollution. Because अब क्या होने वाला है? There will be, as soon as the winter comes, there will be subsidence of an air. So ये पूरा जो summers का pollution है जो upper atmosphere में है, remember it is Delhi, it is not Kerala, Mumbai कि ऊपर से पूरी बारिश हो रही है और वो pollution निकल जा रहा है. This pollution is still lying above Delhi. Fine? जैसे ही anti-cyclone will come, मतलब दिल्ली में winters will come, ये सारा कहाँ पे आएगा? नीचे. at the ground level, subsidence. And plus गाड़ियाँ और उसमें चलेंगे, so it will become more and more dangerous. So small. Fogs hinders the navigation also, means it will cause accidents etc. That is what is known as hinders the navigation. मैं इसलिए अभी short में दे रहा हूँ because I will directly give you one textbook का xerox, different types of fogs. उसमें भी है ground fog, radiation inversion fog, advectional fogs due to surface inversion, due to frontal inversion, mechanical fogs. मतलब whatever the temperature inversions we have studied, उसी के टाइप्स के जो फॉग है, तो 3 टाइप के फॉग है, एडवेक्शनल फॉग्स, नॉन एडवेक्शनल फॉग्स. एडवेक्शनल फॉग इज ऑफ 2 टाइप्स, सरफेस फ्रंटल वैली फॉग्स. नॉन एडवेक्शनल फॉग इज ऑफ 2 टाइप्स, ग्राउंड इन्वर्जन फॉग्स एंड अपर एयर इन्वर्जन फॉग्स एंड मैकेनिकल फॉग्स. फाइन. एंड थर्ड, this, those who don't know, stone becomes very, very cold. There is air. Air becomes cold during the winters, but obviously the stone will become extremely cold. So vapor is converted into by cooling into water, and therefore water droplets will connect on the stones, cars, anything, and this water droplet is what is known as dew. Sometimes vapor by cooling gets converted into liquid, that is water, and liquid by cooling gets converted into solid, that is ice. But sometimes temperature decreases to such an extent that vapor directly becomes solid, and that when is the case, when the vapor directly becomes solid, then it is known as frost. So temperature inversion results into formation of dew and frost, but frost is due to sublimation. What is sublimation? This process is what is known as sublimation. What? Frost? कूलिंग मतलब कंडेंसेशन. ये कंडेंसेशन है, ये भी कंडेंसेशन है, ये भी कंडेंसेशन है. इन फिजिक्स, when one particular state of matter bypasses the middle state and directly becomes the third state, it is known as sublimation. Cooling in geography is condensation. So vapor cool होके liquid बनता है, vapor cool होके frost भी बनता है. Geographically condensation. But क्या है sublimation? कि vapor instead of becoming water, that is dew, directly becomes frost. That is process is known as sublimation. Condensation का ही part है, but that process is known as sublimation. Understanding the difference? Understanding the difference? Clear? Dew is beneficial, frost is harmful. Why frost is harmful? Why it is harmful? For example, मैंने अभी बर्फ लिया और आपके हाथ में ज़बरदस्ती रखा. What will happen? Your blood will get frozen, and ultimately when your body does not get that part blood, वो body का टुकड़ा गिर जाएगा, निकल के. That is what is the frost bite. Frost will cause frost bite. Clear? So significance of temperature inversion. We have done with the topic of temperature. We come to very, very interesting topic, that is the what are the subtopics we are going to study here is pressure belts. Second subtopic which we are going to study is in this subtopic we are going to study exception, that is the and gradient winds. So kal ka lecture you can go today. Kal ka lecture is very important. I am going to take from 2:30 onwards. There is no clashing with current affairs. So gradient winds. Kal ka lecture is going to be very, very important. Today I will do the pressure belts only. The third topic here will be surface winds, जिसमें itself I will do Indian geography का monsoon. Fine. And in the monsoon we will go do all things, that is El Nino, La Nina, Indian Ocean dipole, Madden-Julian oscillation, etc. and the jet streams. Fine. Question frequently, applied question, इसके बारे में तो बताने की ज़रूरत नहीं, इसके बारे में तो बताने की ज़रूरत नहीं. That is why I was checking the paper. सबसे ज़्यादा question is from Köppen, Thornwright and Trivartha, and second largest number of questions are from pressure belts. एक हाथ question कभी कभी आता है regarding the world distribution of the rainfall, etc. So what do you mean by the pressure? Don't write. First we will properly understand. Pressure is nothing but the weight of air on us. Pressure in simple language means the weight of air on us. Now if we are standing here, if we are standing here on this region, and if we are standing here in this region, if the air is coming downwards on us, and if the air is going upwards on us, so कहाँ पे weight ज़्यादा होगा? When the air is subsiding, that is, it is coming on us, and we will call this as an high pressure system. When the air is going upwards, we will call this as a low pressure system. Generally, there are different reasons why the air may come down, why the air may go up. GS में मैं बहुत superficially बताता हूँ again कि air generally comes down when there is a cooling, when the ऊपर की air cold है वो नीचे आएगी. जब नीचे की air warm है, that is during the summer season, the air will go up. I will not tell you this way in the optional. It is caused due to different reasons. It can be dynamic, it can be thermal. Generally the warm air will become expands, it will become lighter, and then it will start going upwards. Fine. The cold air, because it is denser, वो नीचे 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 आएगी. Second thing is, when the air goes upwards, it starts cooling adiabatically. Fine. And when it starts cooling, vapor starts getting converted into water droplets or ice particles. They all join together, and ultimately this will result into formation of clouds. As they result into formation of clouds, this will give rainfall. So low pressure के साथ हमेशा याद रखना there is atmospheric instability, there is chances of precipitation. And जब एयर नीचे आएगी ऑब्वियसली इट इज गोइंग टू गेट वार्म्ड. जितना ज़्यादा गर्म है एयर उतना उसका वाटर वेपर होल्डिंग कैपेसिटी ज़्यादा है. वाटर नहीं, वाटर वेपर होल्डिंग कैपेसिटी, जिसको हम कहेंगे मॉइस्चर होल्डिंग कैपेसिटी. ऑब्वियसली बिकॉज जितना वार्म है एयर उतना वाटर विल गेट इवेपोरेटेड इनटू वाटर वेपर. वाटर वेपर रिक्वायर्स लेस स्पेस देन वाटर एंड देयरफॉर इट कैन स्ट्रॉन्ग. सो इसमें वाटर वेपर होल्डिंग कैपेसिटी इज ग्रेटर. एंड यहाँ पे there are never clouds in the sky, there is cloudless and clear sky, and hence this will promote dry conditions, that is aridity. This is what is known as anticyclonic conditions, not anticyclone. This is what is known as anticyclonic conditions, when the air is forced to come down, and this is what is known as cyclonic conditions, when the air is forced to go up. Fine? Understanding this too? अब इन सब चीज़ों को ध्यान में रखते हुए remember again, no need of this diagram. If this is our earth, if this is the central part, that is the equator, if this is the 90° north and if this is the 90° south, कहाँ पे heat सबसे ज़्यादा है? At the equator. So air will rise up from the equator and it will go up to the tropopause. After going up to the tropopause, this air cannot penetrate the stratosphere, so it will go down and it will settle over the poles. Listen to me. ये मत सोचो ये क्या है, wrong है या right है. It will settle over the poles. And after settling over the poles, this will flow from poles towards the equator and flow from poles towards the equators on the surface जहाँ पे हम है. So इनको हम कहेंगे winds. इनको हम कहेंगे winds. This is convection. This is anticyclones. This is cyclones. This is the first model of the wind circulation in the world. We are not going to do GS, so इसलिए ये हमें पढ़ना पड़ेगा. वैसे ये wrong है. Fine. This is the model of wind circulation in the world, which was given by initially by Hadley, who gave this model. Means initially by Hadley, and later on also the next model was given by Hadley. This model does not consider that the earth is rotating. But obviously this model is wrong, because we don't have just one wind system, we just don't have one convectional belt. In fact, in real life, what happens is, the air from the equator which rises upwards, it goes upwards into the tropopause region, and after going into the tropopause region, this air gets bifurcated into two parts. ऊपर जाके it becomes very heavy. Why? Because it has become cold, so it cannot travel this entire distance, and it will come and settle down somewhere near the somewhere between 30 to 35 degree north and between 30 to 35 degree south. Why the air rises from the equator? Because this region is very, very hot, and therefore we call equatorial belt as the low pressure belt. In which category the equatorial belt falls, low pressure belt? It falls into the thermally induced low pressure belt. Thermally induced matlab, due to extremely high heat, the air is forced to rise upwards. Thermally induced. Fine? क्योंकि इक्वेटर पे बहुत ज़्यादा गर्मी है, बट इक्वेटर से ज़्यादा गर्मी तो यहाँ पे है 30 to 35 degrees. These are the regions of deserts. These are the regions जहाँ पे आज हम है. हमारे थोड़ा ऊपर वाला रीजन, नॉट एग्जैक्टली आवर रीजन बट वी आर समवेयर बिटवीन दिस रीजन, फाइन. So यहाँ पे summers तो are very very hot, it is even hotter than Kerala, it is even hotter than the equator. But then still also, instead of air rising upwards, which should be the rule, air is forced to come down. Why the air is forced to come down? Because यहाँ पे seasons है. Sometimes there is summer, sometimes there is winters. यहाँ पे there is a permanent summer. So as a result of this, this is a permanent low pressure belt. And एक बार हवा यहाँ से ऊपर उठ गई, then this air, because it, after reaching the height of 18 kilometers, it becomes extremely cold, and because of this, it cannot travel this entire distance. वो बीच में ही कहीं तो नीचे आती है, resulting into formation of low pressure belt, high pressure belt, because air is coming down, and we will call this as dynamically induced high pressure belt. Why dynamically induced? In spite of higher temperature, यहाँ पे there is a high pressure. Higher temperature means there should have been low pressure, and therefore these are the regions of deserts. फिर होने के बाद this air from high pressure to the low pressure flows towards the equator, and this winds we will call it as a trade winds. Getting it? Similarly, extremely cold air is settles over the poles in both the hemisphere, because ये बहुत ज़्यादा cold है, high pressure. अब why it is settling? Because this comes in the category of thermally induced high pressure belt. So दोनों extremes, center पे and at two extremes, we have thermally induced low pressure, thermally induced high pressure. Air is forced to come down or air is forced to go up due to temperature. This air, after coming to around 60 to 65 degree latitudes, or coming around 60 to 65 degree latitudes, this air gets automatically warmed, and hence it rises upwards, and as a result of this, it goes. It completes one circle. The question was, why this air which is going upwards does not come in this direction? Why it goes back to its original direction was answered by Sir T.J. Farrell when he discovered that यहाँ पे there is a jet stream. When he discovered that यहाँ पे there is a jet stream. So यहाँ पे this is a high pressure, यहाँ पे there is a high pressure, so बीच में का area automatically becomes a low pressure belt. यहाँ पे 60 to 65 degree north and south should be having, obviously has lower temperatures than 30 to 35 degree, but still because air is forced to rise up, it is called as a high pressure belt. It is a low pressure belt. Why low pressure belt? Because यहाँ पे polar air जो -10, -20 में originate होती है, when it comes to +10 degree Celsius, it is forced to rise up. Therefore, it will come again under the category of dynamically induced high pressure, dynamically induced low pressure. Now, because यहाँ पे air is forced to rise up, red color के this blue color के winds, obviously the polar air is forced to rise up, it automatically develops a low pressure belt, and therefore air from 30 to 35 degree latitude also tries to go towards the 60 to 65 degree latitudes. When it goes to 60 to 65 degree latitudes, it sees कि यहाँ पे तो there is a cold air, they both mix, and therefore there is a zone of, we have just done now, what it is? Fronts. And you have just seen in the fronts, हमेशा fronts में which air is going to rise up? Warm air. So ये भी ऊपर जाती है, ऊपर जाने के बाद इसको भी jet streams दिखता है, it comes down to its original position. And completes a circle. Same, it goes up, there is a formation of fronts, and it comes down to its original position, and there completes a circle. So यहाँ पे this is the zone of fronts, यहाँ पे this is the zone of fronts. Getting it? this wind is known as westerlies, this wind is known as polar easterlies. When the polar easterlies and westerlies join, it results into fronts and temperate cyclone. This wind is known as trade winds. The region where both the trade winds come together is what is known as the ITCZ, Intertropical Convergence Zone. Fine. Now in this intertropical convergence zone, in this region which is between 0 to 5 degree north, 0 to 5 degree south, surface पे कोई ज़्यादा strong wind नहीं है. There is no strong wind at the surface, and because of this there are calm conditions in the sea, and this calm conditions in the sea we will call ITCZ as the belt of doldrums. Getting it? Why it is known as the belt of doldrums? Because of the belt of calm. And because it is a low pressure belt, हमेशा याद रखना यहाँ पे there will always be clouds and rainfall, and therefore tropical evergreen forest. Similarly, in this transition zone between 30 to 35 degrees and between 30 to 35 degrees in this region, जहाँ से एक wind इस direction में जा रही है, दूसरी wind is coming in this direction, this also is a belt of calm conditions. This also is a belt of calm conditions. But because it lies between subtropical regions, not equatorial regions, subtropical regions, which once upon a time were the supplier of raw material in the terms of spices, silk, and this lies in the temperate region which used to do the trading. यहाँ पे हमेशा trading ज़्यादा होती थी, and therefore in this region में आने के बाद the ship used to get stuck because हवा ही नहीं है. So they used to throw the horses after tying the horses to the boat. वो horses को समंदर में फेंक देते थे, horses ताकि तैरे, swim करे और boat अपनी निकल जाए, because the boat used to become lighter, and hence this region is what is known as horse latitudes. वैसे technically this is equatorial low pressure belt, this is subtropical high pressure belt, subtropical high pressure belt, this is subpolar low pressure belt, and this is polar high pressure belt. यहाँ पे there is no question of calm because यहाँ पे हमेशा there is rainfall. So this is the second zone. ये line इसलिए बनाई है because this is a front. This is the second zone जहाँ पे there is a rainfall throughout the year. This is the first zone where there is a rainfall throughout the year. Tropical evergreen forest, evergreen coniferous forest. Fine. बाकी के बीच में deciduous, desert जहाँ पे कभी भी बारिश नहीं है, hot deserts of the world. Deciduous, tropical deciduous, temperate deciduous. This is desert. Why? Because air is coming down, and you know जब भी air नीचे आएगी तो aridity. So air is coming downwards here. This is the region of desert. ये हमारा है. This is a temperate deciduous, evergreen coniferous forest. Because of the snowfall, the trees are conical in shape to protect themselves from the frost bite, so that ice उनके ऊपर जमा नहीं रहेगा. Right? And ये है cold deserts of the world. जहाँ जहाँ high pressure है वहाँ पे deserts है. These are the hot deserts and these are the cold deserts of the world. Clear with the pressure belts? And wind always will flow from high pressure to low pressure. High pressure to low pressure. Can you see in this diagram? Height of the troposphere is going to decrease. Height of the troposphere goes on decreasing. जहाँ convection ज़्यादा है, where is the convection greatest? Where there is heat. Height of the troposphere is greater. And because of this difference in the height, there comes a difference in the temperature. And in the difference in the temperature will result into only difference is this is polar jet, this is subtropical westerly jet, you can see jet streams उसी जगह है जहाँ पे winds के color change हो रहे हैं. Jet streams are not present जहाँ पे the winds are same. Why I use the color? Just to tell you, winds of northern hemisphere, winds of southern hemisphere. Understanding the pressure belts? Any doubts? Clear? 100%? ये हमारे काम का नहीं, ये GS है, इसलिए मैं जो वहाँ पे 2 घंटे में पढ़ाता हूँ, I have taught in half an hour. Understood? कोई doubts नहीं है इसमें? Fine? So we'll meet then tomorrow and start with factors affecting wind. कहाँ पे? Just a minute. Her question is, I forgot to tell you this thing. What is this? Smoke coming from sea. This is also smoke coming from sea. Can you see the smoke? This is कभी-कभी बहुत ज़्यादा smoke coming from sea. Smoke coming from sea. Smoke coming from sea. This is fog which is coming from sea. It is coming from sea. Her question is, sometimes पंजाब के आसपास canals में ऐसे fog बनता है. Tell me what is this? Temperature inversion? No. I would have made you right. This is GK based question. What is this? ऐसे कभी कभी लगता है smoke is coming from the sea. This is not fog, remember. This is cloud and this is the smoke coming from the sea. Or you will find it here. Smoke is coming from the sea. It's not fog. विंटर्स में बाथरूम में जब गर्म पानी होता है स्मोक आता है कि नहीं? फ्रॉम योर बकेट या फ्रॉम गर्म ग्लास. क्यों? There is a hot water in the bucket and therefore there is evaporation, but surrounding air is very cold. So air which comes up starts condensing. Condensation से vapor starts getting converted into water droplets, जो हमें लगता है is a similar to smoke. So जो बाथरूम या कप में हो रहा है वही चीज़ कनाल पे हो रही है या ओशंस पे हो रही है. Oceans का water is warmer, surrounding air is very very cold and therefore when the cold air passes over the oceans, the water evaporation start getting condensed, the evaporated water start getting condensed, and it looks as if smoke is coming from the sea. Getting it? Application हम पढ़ेंगे इसको, yes, air masses. Fine, that's it.